Hello dear viewer, my name is Mr Auma. I'm a teacher by profession and I teach mathematics and physics. So today I want us to look at something under the density bottle. And under the density bottle, I want us to look at the meaning of a density bottle. After looking at the meaning of a density bottle, I also want us to look at what is this density bottle used for. And after looking at that, I'm also going to take you through the precautions that you are supposed to consider while handling a density bottle. And after that, I'm going to finish by doing some two examples and we'll be good to go. So let us just begin straight away as from the definition of a density bottle. Number one, you have to know that a density bottle is a small bottle that is made of glass. And the density bottle, it has a glass stopper. And the stopper that is the density bottle is having has a certain hole in between to allow excess the liquid to flow out. So you have to include all those in the definition of your density bottle. So let us just begin by the definition. You say it is a small glass bottle. It's a small glass bottle. It's a small glass bottle fitted with a glass stopper which has a hole to allow excess liquid to flow. So it is a small glass bottle fitted with a glass stopper which has a hole to allow excess liquid to flow. So I want us to take a look at the diagram, rather a figure of a density bottle. Let us have a drawing here of a density bottle. Yes, the teacher is not good at drawing, but let us just draw something that resembles a density bottle. So a density bottle looks like this. It is made of glass, and from the definition we realize that it has a glass stopper. Let us draw the glass stopper. And we also told that the glass stopper has a hole. It has a hole. It is made of glass. And this hole is to allow excess liquid to flow out. So this one here is a stopper. The stopper is made of glass. The density bottle has a part here called the neck. We are going to look at the function of this neck while looking at the precautions. So it is a small glass bottle, the way it's shown. And I also want us to look at the function of this density bottle. What are we using the density bottle for? The density bottle, it is used to measure. It is used to measure the densities of substances, i.e. some of the substances that you can use to measure their densities using a density bottle is liquids, and solids. So I can take a liquid that I know not about its density and use the density bottle to get the density of that liquid. And at the same time, I can also take a solid that I do not know about its density and use the density bottle to get the density of that solid. So the next thing that I want us to look at is the precautions. The precautions to be considered. Precautions to be considered while using a density bottle. Number one, you are going to realize that there are three precautions. And the first precaution is the bottle is to be held by the neck. The bottle is to be held by the neck. So let's assume that this is my density bottle. If this is my density bottle, this precaution says the bottle is to be held by the neck. The density bottle here has a neck. So I'm supposed to be holding my density bottle this way, not this way. Why am I not supposed to be holding it using my hand this way? Because you realize that the density bottle is made of glass. And the moment I hold, glass can expand and at the same time glass can contract. So if I hold the density bottle using my hand this way, and you realize that my hand has a certain degree of warmth. Therefore, the moment I hold it this way, the density bottle, being that it's made of glass, it will expand. And the moment the density bottle expands, this one is going to interfere with its capacity. If the capacity of the density bottle is interfered with, then we are not going to get the correct density of the substance. Therefore, the density bottle has to be held by the neck. The second precaution that we also have to look at is that the outside of the bottle must be wiped carefully. The outside of the density bottle has to be wiped. Sorry, let me write on the other side. Has to be wiped carefully. Has to be wiped carefully. Why are we supposed to be wiping the outside of the density bottle carefully? Number one thing, has to be wiped carefully. Let me write it so well. Carefully. So, number one thing, you realize that the density bottle is made of glass. And if the density bottle is made of glass, wiping it ruthlessly might make you break the density bottle. So you have to make sure that as you are wiping the outside of the density bottle to keep it dry, you have to make sure you wipe it carefully. The third precaution that we are supposed to take or rather consider while handling a density bottle is that it must be ensured that there are no air bubbles. It must be ensured that there are no air bubbles while filling the bottle. So as you are filling this bottle with a given liquid, or rather as you are filling this bottle with a liquid, you have to make sure that there are no air bubbles left inside it. Why? Why are we trying to exclude the air bubbles? Remember, if you fill this density bottle with a liquid, it's the density of that liquid that you want to determine. And if you leave the air bubbles inside this density bottle, it will interfere with the mass. Why? Because the amount of matter that the air bubbles has is so different from the amount of matter that the liquid could have while, because they occupy the same space. So the amount of matter in the air bubble is going to be different from the amount of matter that is in the liquid, and therefore this one will lead to us getting a wrong mass. And the moment we get a wrong mass, the calculation of the density will also be wrong. The density that we are going to get finally is going to be a misleading density. Or rather, we can say the density will be having an error. And therefore, we have to make sure, or rather, it must be ensured that there are no air bubbles while filling the density bottle. Just ensure that there are no air bubbles while filling the density bottle. So these are the 3 precautions that you're supposed to put into account while using the density bottle. So we have looked at the definition, we have looked at what the density bottle is used for, we have looked at the precautions, and therefore I want us to pick only 2 examples from our KLB physics book. Let me pick up some questions here that are in the KLB book. So let me write here the first example. I hope you are done with this part as far as copying notes is concerned. So let me pick the first example. I'm going to have 2 examples. The first example is going to talk about a liquid, and the other example is going to talk about a solid. So in the liquid, we are going to determine the density of that liquid, and for the solid, we're also going to determine the density of the solid. So in the first example here, example 1, let me indicate it so. Example 1. Let me write this. It reads, the mass of an empty density bottle, the mass of an empty let me write density bottle, dB, density bottle. The mass of a density bottle is 20 grams, full stop. Its mass, when filled with water, its mass when filled, that is F, filled with water. Its mass when filled with water is 40 grams. And 50 grams when filled with liquid X. 50 grams when filled with liquid X. Full stop. Calculate the density of liquid X. Calculate the density of liquid X. Given that the density of water, into bracket, density of water, into bracket, density of water is 1000 kilograms per cubic meters. So that is the first example that we are going to have, we are going to take. Let us do it here. The solution is here. I hope you are also done with this part of the board. So even if I clear it, there is no problem. So the solution. Here is the solution. So what is the question in middle? The question is asking us to calculate the density of liquid X. And we also given into brackets, density of water is 1000 kilograms per cubic meter. This one, it's not a must that you are given the density of water, because it's always assumed that for densities of water, we have to know the density of water. It's either 1000 kilograms per cubic meters, that is in its SI unit, or 1 gram per cubic centimeters. So that is something that as a student you have to put in mind. So our main thing here, the question wants us to get the density of liquid X. But you have to remember we are going to get the density using a density bottle. Before we continue, I want us to remember this. There is this triangle here that always assists us to work out problems of densities, mass, and volume. So you say density is equivalent to mass over volume. So from this triangle here, I can say mass is equivalent to density times volume. And at the same time, I can say volume is equivalent to mass over density. And at the same time, I can also say density is equivalent to mass over volume. So what am I interested in? I'm interested in getting the density of liquid X. So I'll come and say density of liquid X is equivalent to what? The mass of liquid X over the volume of liquid X. So I write mass of liquid X over the volume of liquid X. So for me to proceed, I first of all have to get what is the mass of liquid X. And secondly, I also have to get the volume of liquid X. After getting the mass and the volume of liquid X, therefore I'll be in the position of calculating the density of liquid X. Therefore, I want us to begin as from the mass of liquid X. How do I get the mass of liquid X? Let us come back to the equation here. We interpret the equation. The question reads, the mass of an empty density bottle is 20 grams. Its mass when filled with water is 40 grams and 50 grams when filled with liquid X. So you realize that we have a density bottle. At first, the density bottle is empty and the mass is found to be 20 grams. When this density bottle is filled with water, the mass becomes 40 grams. And if the same density bottle is filled with another liquid, let's say liquid X, this one from the equation here, the mass of the density bottle becomes 50 grams. And what are we in need of? We are in need of the mass of liquid X. Therefore, we'll take the mass of the density bottle filled with the liquid X, then we subtract the mass of the empty density bottle for us to get the mass of liquid X. So you write mass of density bottle, that is dB, plus liquid X minus mass of density bottle when empty. When empty. I'll take it to be, because when filled it's 50 grams, when empty it's 20 grams. So my mass here will be 30 grams. So 30 grams is the mass of liquid X. 30 grams is the mass of liquid X. Sorry. 30 grams is the mass of liquid X. That is the mass. We are now moving to the volume of liquid X. And I want you to get to listen to this carefully, because here is where most of the students fail it. The volume of liquid X. Remember, in the question there, we are not given the capacity of the density bottle. Therefore, we have to first of all get the capacity of the density bottle. And in that question, we are given the mass of water. From the question there, we can get the mass of water. And at the same time, we are also given the density of water. So we can use water to determine the capacity of the density bottle. After getting the capacity of the density bottle, then we shall be in the position of finding if this liquid X, we are told that it filled the density bottle. Therefore, the volume of that liquid X is going to be the same as the capacity of the density bottle. Therefore, let us write here the volume of liquid X. What is the volume of liquid X? We have to know that the volume of liquid X, being that liquid X filled the density bottle, its volume has to be equivalent to the volume of the density bottle. Let me write it dB, density bottle. And you realize that the density bottle that we are given here, we do not know its volume. We don't know its capacity. And therefore, we have to first of all get the capacity of the density bottle. How do we get the capacity of this density bottle? No, sorry, this is an equal sign. The volume of the density bottle is equivalent to the volume. Let me write here. volume of the water, not just water, but the water that filled the dB density bottle. So this one is easy to get. We can get the volume of water that filled the density bottle. Why? Because let us come back to this triangle of ours. We want to get the volume of water that filled the density bottle. From the question, we can get the mass of water that filled that density bottle, and at the same time, we were provided with the density of water. And here I say it's not a mass that will be provided with the density of water. It's upon the student to master that in the mind. So how am I going to get the volume of water that occupied the density bottle? I'll say volume is equals to mass over density. So volume of water is equals to mass over density. Let me represent density by symbol rho. So what is the mass of water? Let us come back to the question. The density bottle when empty is 20 grams, and when filled with water it is 40 grams. So what is the mass of water? I'll take 40 grams, I subtract 20 grams. Because 40 grams is the mass of the density bottle while it is filled with water, and 20 grams is the mass of the density bottle when empty. So I'll take 40 minus 20 as the mass in grams over the density of water. Look at here. We are given the density of water in kilograms per cubic meter. But the mass here is in grams. So it's either we change this one into kilograms or we change the density into grams per cubic centimeters. Let us just change the density into grams per cubic centimeter for this case. Therefore, the density there, the 1000 kilograms per cubic meter is going to be 1 gram per cubic centimeters. So we realize that 40 minus 20, that is giving us 20 grams over 1 gram per cubic centimeters. Grams and grams, they cancel each other, and I'm going to be left with 20 cubic centimeters. So 20 cubic centimeters, this is the volume of water that filled the density bottle. Being that the volume of water that filled the density bottle is 20 cubic centimeters. Therefore, the volume of the density bottle is 20 cubic centimeters. And we also told that we also told that liquid X also filled the density bottle. Therefore, the volume of liquid X is also to be taken as 20 cubic centimeters. So you write, therefore, the volume of liquid X is equivalent to 20 cubic centimeters. Now I can come here again. I wanted to get the density of liquid X. Mass of liquid X that I had gotten to be 30 grams, and I also have the volume of liquid X that I have now gotten to be 20 cubic centimeters. Now let me get the density of liquid X. Let me clear this part. I take the mass of liquid X that we had gotten to be 30 grams. Then I divide by the volume of liquid X, that is 20 cubic centimeters. The 0 and 0 they cancel. 2 goes here 1, 2 goes here 1.5. Then I'm left with 1.5 grams per cubic centimeters. If the question could have asked us to change it into kilograms per cubic meter, I would have just multiplied by 1000 and gotten 1500 kilograms per cubic meter. So this is correct, this is also correct, depending on what you are asked. So that is the first example. The first example is done. I said the first example we are going to look at the density of a liquid, and the liquid we've used is called liquid X. The second example that I want us to do, so let us write here example 2. It is going to determine the density of a solid, Let us take a look at the second example. the second example. Let us also get the second example from one of the questions from the KLB. So the second example reads, the mass over density bottle of volume, the mass of a dB, that is density bottle of volume, 50 cubic centimeters is 10 grams when empty. 10 grams when empty. 10 grams when empty. Full stop. Aluminium tannings. I'm going to represent aluminium tannings as AT. Aluminium tannings are poured. Aluminium tannings are poured. Aluminium tannings are poured into the bottle. Are poured into the bottle. Aluminium tannings are poured into the bottle, and the total mass is 60. And the total mass is 60 grams. Water is then added into the tannings. Water is then added into the tannings. Let me just abbreviate it as T, into the tannings. Or rather, let me write aluminium tannings, AT, aluminium tannings, till the bottle is full. Till the bottle is full. Full stop. If the total mass of the bottle and its content, if the total mass of the bottle and its contents is 90 grams. Is 90 grams. Full stop. Calculate the density of AT, aluminium tannings. Calculate the density of AT. So let us write here solution. So let us write density. This is now density of aluminium tannings, AT. Here is the solution. Let me clear this. So from our triangle here, I'll say that the density of aluminium tannings is equivalent to mass of aluminium tannings, that is 80 over the volume of aluminium tannings, that is also volume of AT. So we remember we are going to use a density bottle, and we have to get the mass of aluminium tannings, and at the same time we also have to get the volume of aluminium tannings. I want us to first of all interpret this question on this other side of the board, so as to get an easy time of calculating it. So in the question here, we are told the mass of a density bottle of volume 50. So the volume of the density bottle, or rather the capacity, we are told volume of dB, that is what? 50 cubic centimeters, is 10 grams when empty. So mass of dB when empty. This is one. This is the second interpretation from the question. The mass of the density bottle when empty is 10 grams. Aluminium tannings are poured into the bottle, and the total mass is 60 grams. So the mass of density bottle plus aluminium tannings from that part, we are told, is 60 grams. Then Water is then added into the aluminium tannings till the bottle is full. From this statement here, we realize that the aluminium tannings did not fill the density bottle. And that is the reason as to why water is now being added to fill the remaining part. So we are told water is then added into the aluminium tannings till the bottle is full. If the total mass of the bottle and its content is 90 grams, calculate the density of aluminium tannings. From that, we get that the mass of the density bottle plus aluminium tannings plus water is now 90 grams. Now, we want to calculate the density of aluminium tannings. This is the interpretation. Now let us go to our calculations. We can now delete this so as to do our calculation on the other side as well. Let us begin as from the mass of aluminium tannings. The mass of aluminium tannings. How can we get the mass of aluminium tannings? We are told the mass of a density bottle when empty is 10 grams. And the mass of density bottle plus the aluminium tannings is 60 grams. Automatically, the mass of aluminium tannings will take 60 minus 10, because this is the mass of the density bottle together with the aluminium tannings, and this is the mass of the density bottle alone. So I'm going to have the mass to be 60 minus 10 grams. I'm going to say the mass of aluminium tannings is 50 grams. I'm done with the mass of aluminium tannings. So simple. Here is where we also have a problem. The volume of aluminium tannings. Now, the volume of AT. Now, I want us to remember this. We have the volume of the density bottle, and we know that the aluminium tannings did not fill the density bottle. The density bottle was partially filled by aluminium tannings, and later it was filled now with water. The remaining part that aluminium tanning left was now filled with water. Now, how can we get the volume of the aluminium tannings? I want you at the back of your mind to have this kind of a drawing. Let's say this is our density bottle. I'm not good at drawing, I say so. But let's say these are the aluminium tannings. They were partially placed, it partially filled the density bottle. So let's say the aluminium tannings occupied a place up to somewhere here. Then the rest of the place was now filled with a liquid. You have to remember that the density bottle has a stopper, so let's say that is the stopper, the sketch. It's just a sketch, yeah, to help us understand.